The isotope radon. Did anybody ever hear of this before? Radon.
Yeah.
You know of it, yeah?
Just heard of it.
You heard of it. Does anyone know why it's important? Or
If it's like stimulating. No.
or perhaps I don't know the chemistry so much. I'm more thinking about in day-to-day life. You see, you're back home. Oh, I forgot, see, but what's your home country? Sudan, that's what I thought, yeah. Are you in a house or an apartment? A house. Back in Malaysia?
Apartment.
Apartment, okay, so it's only really relevant for Siva. Does your house have a basement? It does have a basement. Interesting. So, radon is radioactive and it occurs naturally in the crust of the earth. So sometimes in certain parts of the world, when people build homes and they dig out a basement, they actually dig into a little bit of radon, and this leaks into the basement. So it can be damaging for your health. Now, I suppose it's only really damaging if somebody actually lives in the basement and is around it all the time. Does anyone live in your basement? Oh, so it's probably okay. But you can go into shops here, because I think this is a problem in Ireland. There's lots of naturally occurring radon. You can go into shops and you can get little radon detectors you just put in your basement, and if there's a radon gas, the alarm goes off then, So, I don't know in Sudan. If you've never heard of this before, then maybe it's not a problem in Sudan. Radon in basements? Yeah. Have you ever heard in Malaysia?
No.
No? Or in China?
I don't think.
Have you ever heard of this radon in China? Yeah.
I don't think this was a common in Malaysian houses.
It's not common anyways. Yeah. See, that's the same in Ireland. Basements aren't common.
Yeah.
But maybe that's a good thing, because if you dig into Ireland, I think there's some radon. I don't know what parts of the world. I have a feeling it's more Western, kind of Europe and America. I think all there is oil and gas east under the earth, right? So it was interesting. Like, I don't know, did I tell you this? But do you know where most of the uranium and lithium comes from? Which country does it come from? No, is Australia.
Oh yeah.
Australia has a lot of these uranium and lithium mines. So that's what I mean. Different parts of the world will have different things under the crust. So radon-222, which is a gas, has a half-life of 2.8 days. Some radon has leaked out of a container into the physics lab, and we think 25 grams has leaked out. How long until less than 1 gram of radon remains? Okay, so you start off with 25 grams, and then after one half-life, how much will you have? 12.5. And then again? 6.25. And then? 3.125. And then? 1.5625. And then this is the last one where you have less than 1 gram now. So that's 1, 2, 3, 4, 5 half-lives. So the answer will be 5 times 2.8 days, which I think is 2 weeks.
14 days,
yeah. Yeah, 2 weeks then. Is that okay?
Yeah.
Yeah, right. You need a minute to write that down? Or you got this done in class, did you? Yeah. That's a less than 1 gram. Did I tell you guys I'm studying another master's? Did I tell you this?
You did last year, but not.
No, last year I was doing a higher diploma.
Yeah.
And this year I'm doing another master's. It's an online master's, so you can do all the work on Moodle, So for one of our courses, we're put into group work. So you're in groups of 4, and you're each supposed to do a quarter of the work. So like I have my quarter done, and it's been done for about 2 weeks, and the other 3 quarters
Not that,
is not done, and the assignment's due in 5 days. So I think this is a different philosophy between teachers and students when it comes to doing work, right? Students like to wait a little bit towards the end. Gets more exciting, more interesting, yeah.
There's a kind of pressure.
That's it, yeah. It's funny, whereas I'm thinking, I just want to get this done and get it out of the way, Different personalities. Yeah.
There's a kind of pressure.
Yeah, you operate better under pressure, is it?
Sometimes.
Sometimes, yeah. Huh?
Faster.
Faster, okay. Very good. Right, what is the K constant? So, Andek, do you have the formula? Chell should have the formula too.
T half equals to ln 2 over lambda.
ln 2 over lambda, very good. So lambda would equal log 2 over t a half.
Yeah.
So what is that now?
ln 2 over 2.8.
Yeah, what is that as a decimal, please?
0.248.
248. And the unit?
No,
Oh, you lose a mark too.
unit, second?
Mm-mm. Siba, what's the unit?
4.
The lambda?
Per hour.
Not this time. Look at the question. Look at the question.
Days.
Per day. Per day. Okay. And the nice thing about my masters is that one of the subjects I have to do is maths, which is so not any work for me. So I had 2 tests. The first test I got 100. The second test I got 100. No problem. So it's nice. So I'm supposed to be doing 4 subjects, but it's only really like 2 subjects. It's less stressful. C. What is the activity? Note that the molar mass of radon is about 222 grams. Okay, so here's the thing. The activity will equal minus lambda n. Now, this is where you have to be really careful. Really, really careful, because what unit do we measure activity in? Who remembers? Yeah, do you want to check? What's the unit for activity? Oh no, not activity. Guys, what's the unit for activity? Becquerels, yeah. What is a becquerel? I gave you the definition, yeah. Becquerel per second. Per second. So, if this side of the equation is going to be using per seconds, then this side should also be using per seconds. Yeah, that's it. So our 0.248, whoops, our 0.248 will have to multiply it by 24 and 3600. Now, do we know the n? Do we know the n? How much radon do we have? 25 grams. Yeah? How much is 1 mole of radon? How many grams in a mole of radon? I say 222 grams. Yeah? So how many moles of radon do I have? I'd have 25 over 222. That's moles, but I don't want moles, I want number. So what do I multiply this by? Avogadro, yeah. And this will be our answer for the activity in becquerels. So what is that, please?
Minus 1.45
Yeah.
times
27. Okay, that's a pretty high activity. Okay, continue. How long until there's 1 gram in the room? Okay, so we use our formula n equals n0 e minus lambda t. So n equals n0 e minus lambda, and we'll use days, t. So you're probably sick of seeing this. You know exactly how this is solved, right? We'll just jump straight to the answer. There'll be a minus 0.248, and on the top there'll be a log 0.001 divided by 0.025. So let's get that. So basically 13 days. Okay, continue. Yeah? E. If the room is 20 by 30 by 3, then what's the density of radon? Okay, so what's the formula for density? Mass over volume. And the mass, I tell you, is 1 gram. And the volume is 20 by 30 by 3. So that's 0.001 over 1800, I think. Oh, yeah, go on, yeah, that's it, yeah. What's that?
5.56 times 10 to the
minus 7 kilograms per meter cubed. Yeah? And then the last part for number 1, F. What is the molarity? Now, you know molarity from chemistry. What's the formula for molarity? Do you know molarity? It's moles per litre. Yeah? What letter is that in chemistry? M, isn't it? So that's the number of moles over the volume in litres. Okay? Now the number of moles, that's easy to work out because you have 1 gram and the molar mass is 222. So it's just 1 over 222. But you'll need to work out the volume in litres. Now the volume is 1800, but that guy is in meters cubed. Does anyone know how to change a meter cubed into litres? That is, how many litres are in 1 meter cubed? How many? Not the same. No, because think about it. 1 litre is only like this big. 1,000. Yeah. Like 1 litre is like what? 4 of these?
1 litre.
1 litre, yeah. And 1 metre cubed is quite big. Yeah. So you're right, it's exactly 1,000. 1,000. So here I should put in 000. Okay, so what's the answer here for this? It should be very small. Times 10 to the minus 9 moles per litre.
2.50.
Oh, 2.5. Yeah? Okay, number 2. Scroll down. Shell? Yeah, okay. 2. So that graph there on the y-axis is activity and on the x-axis is time. What's the activity at the beginning? 80 equals. Yeah. Using this graph, what is the half-life? Look at the graph and tell me what is the half-life.
15.
15? 15 days?
I mean, because that's 10 days then.
Huh?
No, 10
I
minutes.
think you're getting a bit confused.
Yeah.
And yet it is. Come on. What's the half-life? You can work it out. I'll give you a clue. What's the activity at the beginning?
It's 80.
Think about
Oh,
that.
sorry.
But that's not the half-life. That's just what half of 80 is. So what's the half-life? Remember, it's in time. Half-life is time.
So it's in 5 days.
Mm-mm.
2.
Thank you, Chow. 2 days. Because the activity is 80 at the beginning. How long until you have 40? 2 days. Yeah. Yeah. Okay. I should worry. All right. B. Now, let's try and work out when will we have 1 equal. Okay, so we start off with 80. Then we get 40 after 2 days. Then we get 20. Then we get 10, 5, 2.5, 1 1/4, and then we now have less than 1. So that's 1, 2, 3, 4, 5, 6, 7. 7 half-lives. That's 14 days. Or in other words, 2 weeks. Yeah? See? Yeah? See now?
Mm-hmm.
So, in the question I tell you that the, this, whatever it is, I don't even know what it is, something. I don't even know what's decaying. I just say it's radioactive. So whatever it is inside of a box. And the box is a volume of 10 centimeters cubed, which is actually a very small. You must have a very small sample of it, like in a little container. Okay. Right. Fine. Okay. Part C. The World Health Organization, WHO, recommends that the maximum level for humans is 100 becquerels per meter cubed. Okay, so look, at the beginning, what's the activity here? It's 80 becquerels, right? Now, that is not per meter cubed. That's only in a box per 10 centimeters cubed. Yeah? Now, what I need to do is convert this into meters cubed. I think the easiest way to think about it is like this. If I have a box here that's 1 meter cubed, each side is 100 centimeters. Yeah? So that's 10 to the power of 6 cm cubed. A million. Do I have a million? No, I only have 10 to the power of 1. So what I'll do is I'll multiply both sides by 10 to the 5. 1, 2, 3, 4, 5 per 10 to the 6 cm cubed. So that's 8 times 1, 2, 3, 4, 5, 6 becquerels per, and 10 to the 6, that's 1 meter cubed. Okay. Now you can see that is too much, because it says here the World Health Organization says the safe amount should be 100. The safe amount should be 100 BQ per meter cubed. Okay? So my question is, how long do we have to wait until this becomes a safe amount? Okay, well let's just work it out using our method of just halving it. So we start off with 8 times 10 to the 6, and if we wait a little bit of time, the activity will become what? If we wait 2 days, what will it become? Don't be shy, you know what it is. If you wait 2 days, how much activity do you have? Yeah, which is?
4.
What? What's half of 8?
4.
Very good. Okay. And half again?
2.
And half again? So that's just 10 to the 6. Or in other words, that's a million. Yeah? And now that's 500,000. That's 125,000. Do I have enough space? What's that?
625. No,
64,500, isn't it?
no,
I think so.
60.
Oh no, it's not. Sorry, I lie. Thank you, Andex. 62500. 31,250. Now remember, I'm trying to get to 100. Okay, I'm just going to be rough now. Okay, I'm getting tired of this. This is about 16,000. Sorry, I'm being so lazy now. This is about 8,000. This is about 4,000. This is about 2,000. This is about 1,000. This is about 500. This is about 250. So around about here we get about 100. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think 15. Now the way we can check. Did I think it's 16?
500 should be 250.
Okay. Well, here, this is how we can check. If you can type in this, we can see if this makes it equal to less than 100. Okay, we'll need to do one more then. So we'll say 17 times 2 days. Yeah, so in other words, I'd say it's about 1 month. About 1 month, right? A little bit more than a month. Okay, can I close this? Ciao?